Hi folks, welcome to another installment. We're going to look still at quadratics, of course, and we're talking about now, we looked already at what happens if we change the value of a, what happens to the graph of our quadratic function or our parabola. And so today we're going to look at the effects of b and c and see what that does to the graph, okay? So we're going to talk about graphing y equals x squared. Now we're just going to include this linear term first of all. And we're going to put a whole bunch of different values of b in there and see what happens. And then we're going to throw that out again, and we're just going to look at what happens if we include a constant term again and try different values of c and see what that does to the graph. Then we're going to talk about the sort of general effects of what b and c do to the graph of our regular old parabola, if we leave a at 1 for now. Okay, and then we'll mix it all together later. So first, let's look at varying the value of b. All right, so you can see what we've got here are four parabolas graphed on this left side over here. So we've got y equals x squared plus x squared plus 2x, and x squared plus 3x. Okay, so what we're doing is we're putting in some different values of b into the equation to see what happens. And you can see that when we just change the value of b by increasing it, the graph shifts both to the left and it shifts downward as well. Okay. Now, I think there's a bit of a typo here. I think these should all be negative numbers. That would make more sense. So, over here, sorry about that, but if we look over here, we start with y equals x squared, and then we're going to go x squared minus x squared minus 2x, x squared minus 3x, so using some negative values of b. So these were the positive values, made it go left and down. And then if we look at some negative values of b, we got a similar effect. It goes to the right, it shifts it to the right, and it also shifts it down. Now, we got to sort of get past our brains in terms of the way that they try to do generalizing 3D images and stuff. I mean, you look at those pictures and all of a sudden I'm seeing like a 3D image, huh? But what we want to do is get past that for a minute. And one of the tricks our mind tends to play on us here is it looks like some of these parabolas are bigger than the others. But every parabola that's graphed on this page is identical in size and shape. If I took any one of them and I sort of superimposed it on top of any of the others, you would cover it over entirely because they are the same. It looks like, for instance, here as we come out this way that they're getting bigger, but they're not. Look carefully and think about what would happen if you just dragged one on top of the other. They're actually the same. So another effect that we have to see there is that there's no change to the size and shape. And there's one more thing I want to point out. All the parabolas that we have graphed here have one point in common, okay? And it's the vertex on the original parabola, y equals x squared, but it's not the vertex of any of the others. There is one important thing about it, though. It's one of the x-intercepts, because they all seem to hit the x-axis twice, so it's got two x-intercepts. But it is the only y-intercept for all of them, okay? So for these, they all have, that's a really strange thing to notice, but they all have the same y-intercept. So no matter what number we choose for b, it doesn't change the y-intercept. It always stays at that one point. That's interesting. Okay, let's roll along. So we're going to talk about some of those effects. So what things did we see? We had no change to size and shape. So that was the same. No change to our direction of opening. So we had no change to size and shape. They all went shifted. When we changed the value of b, we always shifted left, right, and up, down, just depending on what sign we chose. So it shifted left and right or up and down, but b can move it in all four directions there, okay? And we kept the same y-intercept, okay? So that was a weird thing. So no change to the size and shape, and it didn't flip anything upside down, so we had no reflections at all either. So no reflections. Okay, interesting. So let's think about the four properties that are listed here and what effect the value of b had. Did it affect the vertex? Yes. It went left, right, and it could also have gone up and down. So b moved the vertex all over the place. Did it affect the axis of symmetry? Yeah, let's take a look back for a sec. Axis of symmetry went shifting left or right, that line of symmetry down through the middle for different values of b. So yes, of course, it affected the axis of symmetry. Did it affect the direction of opening? No, because for the direction of opening, we had no reflections at all. And did it affect the y-intercept? No. So what did it affect? Just where the vertex was and where the axis of symmetry was. So basically the location of the parabola, but nothing else about it. Okay? Let's look at the value of c now, and this is a little more self-evident. It's easier to see. Pun intended. So if we have y equals x squared, and y equals x squared minus 1, what happens? Well, the whole thing drops down 1 unit. X squared minus 2 drops down 2 units. X squared minus 3 drops down 3 units, etc. And if we go plus 1, plus 2, plus 3, same idea. We just shift the whole graph up or down. But there seems to be this value of c. All it can do is move it up or down. I also want you to notice a correspondence between the value of c and where the graph crosses the y-axis. That y-intercept, they're always the same number. So this one here has a value of 1, 1, etc. Okay? So what are the effects? Shifts up and down. Okay, and that's it. Nothing else. So there's no other effect on the graph there at all. So it just shifts it up and down and nothing else. Okay? So what about the vertex? Yep. It is affected. It goes up or down. Sorry, not down or down. Up or down. What about the axis of symmetry? Well, if we only shift up or down, take a look back for a sec, the axis of symmetry doesn't move because that's a vertical line. So no effect on the axis of symmetry. Direction of opening, no effect there. Y-intercept, yes. It looks like our y-intercept is actually always equal to the value of c. That's what we noticed. Okay? So both b and c change the position of the graph, but not the shape or the direction of opening. Varying the value of b moves the graph vertically and horizontally. It affects the x and y coordinates of the vertex and the location of the axis of symmetry. Okay, so that's sort of the b stuff right here. The c stuff moves it vertically only, up or down, and the value of c affects the y coordinate of the vertex and the location of the y-intercept. That's a big one. All quadratics in standard form, the y-intercept is given by 0, c. So the value of c takes you right to your y-intercept. Thanks.